Hello students, welcome to today's session. Now yesterday I had given you the definition of probability. Now just a recap of that, okay? So I had given you the formula also. So probability of A is equal to M divided by N. Fine? Okay. Now we have one more definition. This is called complementary event. Okay? Complementary event. Now let us assume that you have a random experiment. So this experiment has n number of exhaustive cases. Okay? Or you say exhaustive outcomes, right? Now let A be an event of the random experiment. Now let us assume that out of these n, same definition I am going back, out of these n outcomes, m outcomes are favoring the event A. So is it clear? See, I'll read it out. Let us assume that there is a random experiment. It means it has a sample space. In the sample space there are about n exhaustive number of outcomes. Let A be an event of the random experiment. So if at all this A has to occur, that means out of this n outcomes, m of them are favoring the event A. Okay, so therefore by the definition of probability we have P of A will be m by n, correct? So by the definition of probability we have P of A equal to m by n. So that means the sample space S has how many n outcomes? For this A is one event. For the happening of event A, m of them are favoring. This is how it is. Now if out of n, m of them are favoring event A, then there is the other event that is called the complementary event. So if A is an event of the random experiment, A bar is called the complementary event of the random experiment. In other words, now you say a coin is there, right? If you toss a coin, suppose you say A is the event of getting the head. What will be the absence of head? That is the other event, that is called tail. So if this becomes A, then this becomes A bar. Are you able to follow? Presence of A is head. Absence of A, that is denoted by A bar, and that is equal to T. That is tail. So here also in the same way, out of n outcomes, m of them are favoring A. So therefore the remaining, how many n minus m will be favoring the event A bar. So I will illustrate this again with the help of an example. Now this is the general format I am giving you. Okay. So when you take this definition, how did you get this one? M is number of favorable outcomes to A divided by number of exhaustive outcomes. So the last class I have given you the definition, right? So now using the same definition, so you say probability of A bar will become now the number of favorable outcomes to A bar, okay, divided by the number of exhaustive outcomes. Okay, now out of S, n are exhaustive, so this will be n. Now for the event A bar, how many are favoring? So it becomes n minus m. So I'll repeat it. Out of n exhaustive outcomes, m of them are favoring A. So the remaining n minus m will be favoring event A bar. So therefore probability of A bar will become n minus m divided by n. So now you see, so I'll take this here. So probability of A bar equal to n minus m by n. You can split this one, it's a common LCM. So this will become now n divided by n minus of m by n. Okay. So probability of A bar equal to, now you can cancel, this becomes 1 by 1 minus m by n. Now what is this m by n? This is nothing but probability of A. So therefore you have probability of A bar equal to 1 minus probability of A. So you can just rewrite this, take minus P of A, that is probability of A, to the other side. So first one you will have probability of A, I am taking this to the other side, this will minus will become plus probability of A bar. Now this is equal to 1. Now this one you will have to remember. So as I told you, next year, that is in second PU, many a times you will be making use of this. So probability of event plus probability of its complementary event will always be equal to 1. So using this you can rewrite this one more. So you can write, so P of A will become, take this to the other side. So 1 minus probability of A bar. One more, probability of, I'll take this here, A bar equal to, take this to the other side, 1 minus probability of A. Now these three are very important whenever you are solving any problems here. Is it clear? So you can always remember probability of an event plus probability of its complementary event. Now that should always be equal to 1. Okay. Now this is the general proof you have. Now other than this, yesterday I told you last session, the two more definitions are there. So I will define those two now. So the first one you have what is called as union of events. Now let us assume that A is one event, B is another event of the random experiment. Then the union of these two events is denoted by A union B. Okay. Now whatever you have learnt in the high school, the same notation we are using here. Union is denoted by A union B. Now this is a set which contains those outcomes which may be present in A or it may be present in B. So I'll repeat it. See, suppose A and B are two events of a random experiment. Then of course A has certain outcomes, B has certain outcomes. Then the union of these two outcomes is given by A union B. Now this union is a set of outcomes which are present either in A or in B. In other words, whenever you have A union B, now you can represent this by A or B, or we sometimes will be using this as A plus B. All the three are allowed here. A union B, or you write A or B, or you write A plus B. Okay. Now to give you an example, now let A be 1 and 2. So I am taking the die experiment. So B be equal to, so 3, 4, 5, 6. Okay. Therefore A union B will be, so 1 and 2 are in A and the other rest of them are in B. So you will be writing like this. So it is a set which contains those outcomes which are in A or those outcomes which are in B. Now by chance, say A has 1, 2, 3, 4. Okay. Now B has say 3, 4, 5, 6. Then also A union B will become, now you will write 1, 2, 3, 4 of which one? A. And then these two are repeated. So you don't have to repeat that. The other two which are there, so you will be writing this as 5 and 6. Okay. The next one you have, now what is called as intersection. Intersection of events. Okay. Now same definition. Let A and B be any two events of a random experiment. Then the intersection of these two events is denoted like this. A, it is inverse U. A intersection B. Now this is a set which contains those outcomes which are present both in A as well as in B. So which contains the outcomes which are present both in A as well as in B. Okay. Now this A intersection B is denoted by A into B, or otherwise you say A and B. Okay, like this it is. Now to give you the example, I'll take the same example. Okay, fine. Let A be 1, 2, 3, 4, B be equal to 3, 4, 5, 6. Then, now you see, A intersection B will be, so those elements which should be present in A as well as in B. So which are those elements which are present in A as well as in B? So A intersection will become now 3 and 4. Now this is how you have to work it out. Okay. Okay. Now next I'll be working out a few problems based on the definition of probability. Okay. Now, so first problem. Let us assume that a coin is tossed. Now normally we have this word what is called as unbiased, or you say fair. So it means that, so head is on one side, the tail outcome is on the other side. So normally whenever we are writing the problem, we usually say a fair coin is tossed once, or we say a unbiased coin is tossed once. Okay. Now the question says like this, see. Let a fair coin be tossed once, then find the probability of, so first one, getting the outcome head. Okay, getting the outcome head, or you simply say getting head. Now second one, getting the outcome tail. So very simple problem. So now see how many coins? Only one coin. So single coin. So first you will write the sample space. So S is H comma T. Okay. Then come to the first question. Getting the outcome, what is it? Head. So you will write this as A. A is what? Head. Okay. Now probability of A. Now yesterday's or today's definition we have given you. M divided by N. So here this is, I told you, this is your N value. Now this is your M value. N is how many? So N 1, 2. So N is 2. Here M is how many? Only 1. So therefore this becomes now 1 by 2. Okay. Now the next one you have getting tail. So here since there are only 2, either you can take this as B, or if you want you can take it as A bar also. So if I take this as A bar, now this will be tail. So probability of, now you see A bar equal to, same way here, M is now 1, N is 2. So M divided by N again here. I am using the same definition M by N. I am treating this as one even now. So 1 divided by 2. So this is also 1 by 2. Now if you go back the previous definition, what I had just written now. So I just proved this, probability of A plus probability of A bar is 1. Now you see here, this is half. Now this is also half. So therefore half plus half is 2 by 2. So definitely you will get this as equal to 1. So in all the problems wherein you are using the probability, so in all the examples you will always see that this will always hold good, irrespective of the number of events you have. Okay. Okay, now let me extend this problem now. Instead of one coin, now let us take now 2 coins. Now if you are able to understand the logic, it is a very interesting problem chapter this is, okay. And we are using those problems which are all realistic. So you say that second problem, okay? Two fair coins, or you say two unbiased, fine. Two unbiased coins are tossed once. Find the probability of getting. So now you can have both heads. Second one, no heads. Third one, one head and one tail. Okay. Now here how many coins? So two coins. So sample space. So I told in the last session, two coins, each has two sides. So the total number will be, exhaustive outcomes will be 4. So S will become now HH, TT, HT, TH. So first one is both heads. So both heads means this is the event. So you say A equal to HH. So probability of A equal to M by N. Now this is equal to, now you see here how many are there? 1, 2, 3, 4. So N is equal to 4. So here only one possibility. So M is equal to 1. So therefore this will become now 1 divided by 4. Okay. Now coming to the second one. No heads. Now what does it mean? No heads means this is the event that is asked. So the question may be asked, find the probability of getting no heads, or it may be asked as find the probability of getting two tails, or find the probability of both tails. So if I take this as event B, okay, so TT, so this is equal to, now probability of B, now this is equal to M by N. So same type, this is 1, this is 4, so therefore this will become now 1 by 4, okay. Now coming to this, one head and one tail. Okay. Now when you take here one head and one tail, it is understood. So if it is one head, the other one definitely should be a tail. So therefore for this, if you take this as C. So what are the possibilities? Two possibilities are there. First one head, second one tail, or first one tail, second one head. HT and TH. So here what happens now, M is two possibilities, M is 2. So probability of C, M by N. Okay, fine. So this is now 2 divided by 4. Or you can take it as, if you cancel, it becomes 1 by 2. Now here also you see, all the, if you take here the probability, it will hold good. Now first part is 1 by 4. Now this part is also 1 by 4. Now this part is 2 by 4. That complementary, I said, right? 1 plus 2, so plus 2. So 4 by 4. Now if you cancel, you get the total probability to be equal to 1. Okay? This is equal, okay. So like this you can go on extending. So in the next one will become now 3 unbiased coins are tossed once. Find the probability of getting. So first one you can write all heads. Now second one, so I can take it as all tails or 3 tails, however you wish you can write the question. So third one, 2 heads and 1 tail. So if you want one more I can add, so 1 head and 2 tails. Now I'll just read out the question, you see. Three unbiased coins are tossed once. Find the probability of getting all heads, 3 tails, 2 heads and 1 tail, 1 head and 2 tails. So here 3 coins are tossed. How many times? Once. So each of the coin has 2 sides. So the total number of exhaustive cases will become now 8. So if you write the sample space, now very easy method I'll teach you. So first you do all the 3. So 3 coins, all the 3 of them are showing head. So you reverse this one. So T, T, T. Okay. Then you make this 3 as 2 now. So 2 heads, 1 tail. Now next reverse this. So 2 T, T, 1 head. Then 2 will become now 1 head, 2 tails. Then this is opposite or reverse, whatever it is. So this will become T, H, H. So the other leftover, one is H, T, H, another one is reverse, T, H, T. Now count here 1, 2, 3, 4, 5, 6, 7, 8. Now that is what you get here, 8. Okay. Just go through that one. Now first one, all heads means what? We want only this outcome. So A is all of them are showing heads. So H, H, H. Now here what is M value? This is only 1. Once it is possible. How many it is N here? 8. So probability of A, M by N. So 1 divided by 8. Okay. Now coming to the second one. 3 tails. Now this is the only possibility you have. So if you take this as B, event of getting 3 tails. So therefore probability of B equal to M by N. How many possibilities? Only once. Out of how many? So again same way. 1 divided by 8. Okay. Now coming to the second one. So this is 2 heads and 1 tail. So if you take this way, see, C is 2 heads. So which are those possibilities? This is 1. So HHT. Another one is this is T, HH. Okay. Another one is this one. HTH. Anything else is there? Just see. Only 3 possibilities are there. So therefore probability of C equal to M by N. So M is now 3. So N is now 3 by 8. This is how you have to work it out. Now the next one is also same thing. Now 1 head. So D is 1 head. So which are those possibilities? This one. So H, T, T. Another one, 2 tails. That's what. Here. One more is this, right? So I forgot. Okay, this one we can take T, T, H. Now another one is this one. T, H, T. So again you see. So probability of D. Now again this will become now with the same formula. You say 3 by 8. Now here also if you add here, so all of them will become equal now. 1 by 8 plus 1 by 8 plus 3 by 8 plus 3 by 8. So 3 plus 3, 6 plus 1, 7 plus 1, 8. So 8 by 8. So the total probability is equal to 1. Okay. Okay, now we have done problems based on coins and the die. Now there was one more example I had given you, the playing cards, right? Okay. Now if at all you have any problem on the playing cards. Now here the problem says like this. A card is drawn from a pack of playing cards. A card is drawn from a pack of playing cards. Find the probability of having. Now you can have, see first one, king card. Now second one, queen card. So red card. Diamond card. Okay. Now, last session I explained to you. So the total number of cards is now 52. Now in this case, like unlike that coin and die, you cannot write the sample space. Now here you will have to go back to your permutation and combination. Remember, in that we are using the selection here. In other words, we will be using the concept of selection, or you say combination. So if you remember that, so if there are n numbers, out of which if x numbers are to be selected, the total number of combination is NCX. Okay. So if there are 5 cards, if you are drawing 2 cards out of the 5 cards, the number of possible ways of selection will become 5C2. So you'll have to use that one. Now here, how many cards are there? There are 52 cards. So therefore, denominator, whatever you write, that will be your exhaustive cases. Now here, numerator, what you are going to write, that will be your favorable cases. Okay. Now here, the total first you will take. Exhaustive, that means how many cards are there in the pack. So there are 52. How many cards are you drawing? 1 card. So number of possible ways will become 52C1. So 1 card you are drawing out of 52 cards. So therefore the possible selections will become 52C1. This will be your exhaustive cases. Okay. Now coming to the favorable cases. So king cards. So in each of the set you will have 1 king card, 1 diamond king card, 1 heart king card, 1 spade king card, another one will be the club card, king card. So 4 king cards are there. So therefore number of favorable outcomes will become 4. So therefore 1 out of 4. So it becomes now 4C1. So how will you write this one? So the same way. A is the event of drawing a king card. So therefore probability of A will become M by N. So this will become now 52C1 divided by 4C1. Now all of you are aware of the fact 4C1, it is like your NC1. So what is NC1? It is N. So therefore this will become now 4, 52C1 will be 52. If you want, you can further simplify. Okay. Now same way. So queen cards, how many are there? There are again 4 queen cards. So if you take this as B, so B is the event of drawing a queen card. Fine. So probability of B. Same thing you will have to write. M by N. So 4C1 divided by 52C1. So therefore this is again 4 by 52, or you can cancel, that will become 1 by 13. Okay. Now coming to the red cards. So how many red cards are there? There are 26 red cards. Correct? So number of red cards is 26. So 13 are heart red card, heart, that is red color in color. Another 13 are your diamond cards. So therefore put together this is 13. So therefore this will become now C is the event of getting a red card. So probability of C, M by N. Now this will become 13. So 26, right? 13 plus 13. 26 C1 divided by 52 C1. Okay. Now on the other hand, if you take this diamond, there are only 13. So same thing you will write. So D is the event of drawing a diamond card. So probability of D, M by N. How many diamond cards? Only 13. So 13 C1 divided by 52 C1. Of course you can write this as 26 by 52. Now this will become now 13 divided by 52. Suppose there are 2 cards now. So if 2 cards are drawn, you can have the same way. 2 cards are drawn from pack of playing cards. Find the probability of having. So 2 king cards, or you can say 1 king card, 1 queen card, or you can say 2 red cards, or you can say 1 red card, 1 black card. So like that, okay. So 2 cards are drawn, same thing I have to write, 2 cards are drawn from a pack of playing cards. Find the probability of having or getting. Find the probability of getting. So first one, 2 king cards. Second one, 2 black cards. Now you see. Now the only change is instead of NC, X is there, right? 1, NC1. So you will have to take C2, that's all. Now here you see 2 king cards. So A is the event of drawing 2 king cards. So probability of A, M by N. So out of 52, now you are drawing 2 cards. So number of possible ways is 52, C2. How many king cards are there? 4 are there. Out of 4 you are drawing 2. So therefore it becomes 4C2. Of course this you will have to simplify later on. Okay. Now coming to black cards. How many black cards are there? So B. So this is 2 black cards. So how many black cards are there? 26. So this will be same 52 C2. Now number of black cards is 26. So out of 26, 2. So 26 C2. Okay. Now, the next one you can use your union and intersection. Okay. Now for the same problem, now I can rewrite the question. See, find the probability of getting a king card and a queen card. Okay, I'll just make this small change. A king card or a queen card. Now see, here instead of 1, I'll make it as a card is drawn, right? A card is drawn from a pack of playing cards. Find the probability of getting a king card or a queen card. So B, a red card, red colored it is actually, okay? A red card or a black card. Now you can further have a diamond card or a spade card. So I'll read it out. A card is drawn from a pack of playing cards. Find the probability of getting a king card or a queen card. Next, a red card or a black card, a diamond card or a spade card. Now coming to the first part. So first one, A. Now this card has to be a king or it has to be queen. So if you take this as A, this as B. So A or is it? So what is it? Or is it? So it becomes like this, A or B. So what you have to do is, probability of A will become now, here this will remain the same. So 52 C1, there is no change here. But when you are having R, so R means I told you, it means it is A union B, or it means it is A plus B. So what you will do, whenever you have R, you will just put one plus sign. First part is A. What is A? A is the event of drawing a king card. How many king card are there? 4 are there. So this will become 1 out of 4. So 4C1. Now next R. When R is there, you will put this as plus. Now queen card. 1 has to be queen card. Out of how many? 4 queen cards are there. Therefore this will become now 4C1. So you will say 4C1 plus 4C1 divided by 52C1. So what is 4C1? It is 4 plus this is also 4 divided by 52. So this will become now 8 divided by 52. So whenever you are having R means union, union means plus. The plus has to be written only in the numerator. Okay. Now same way here the red card or black card. So if you take this is B. So a red card or black card. So probability of B. Now you will make the same changes here. So this is same 52C1. R is there, so plus. Red cards how many are there? 26 are there. 1 out of that. So 26C1. Now black cards how many are there? 26. So 26C1. So same way this will become now 26 plus 26. Now divided by 52. Now this will, anyway that will be 52 by 52. It will be equal to 1. Okay. Now coming to the diamond card. So diamond how many are there? 13 are there. So therefore 13C1. R is there again. So you will put plus. Spade how many are there? 13 are there. Again this will become 13C1 divided by 52C1. Again you will do the simplification here. 13 plus 13. Okay. Now divided by 52. So in other words it will become now 26 divided by 52. So here which concept have we used? We have used the concept of union. A union B. Now the next concept we will be using the intersection. So if that is the case, the question will become now, see, 2 cards are drawn from a pack of cards. Find the probability of getting a king and a queen card. A king and a queen card. So second one, a red card and a black card. So you can have the same type. So next one, a diamond and, so if you want you can take heart also, no problem, a heart card. So in one more way you can say, so if 2 cards are drawn from a pack of cards, what is the probability that one is a king, other one is queen. One is red and the other one is black. One is diamond and the other one is heart. Okay. Now what is the change here? 2 cards. So therefore it becomes now exhaustive will become 52. So A will be the event of drawing 2 cards here. So out of 2 cards, 1 should be a king and is there. See, 2 cards. So 1 is king and 1 is queen. So whenever you have and, so you have to remember it is intersection. So it will become now probability of A will be, the change will be now 2 cards. So you will write it as 52 C2 and is there. So you just put the multiplication sign. First one is king. So okay. So how many king? So 1 out of 4. 4C1 into how many queen? 1 out of how many? 4C1. Now this will be the difference here. Okay. So 4 into 4 it will become now divided by 52 C2. Of course you will have to do the simplification, right? Now next one, same way you take here. I'll just write it on. So probability of B. Now 2 cards are there. One should be red and the other one should be black. So red cards how many are there? So 26. So 26C1 into, now and is there, so we put multiplication. Black card 26 are there. So 26 C1 divided by 52 C2. This will be your probability of B. Okay. Okay, I think this is enough for today's class. Thank you.